और कौन सा फर्स्ट होता है?
Morning, everyone. Please sit down. So, where did we stop last class? तू भी इधर आ जा, क्या नाम है इसका? हर्ष, कम से and clear the aisle. Where did we stop last class? Less than 60 was done. Okay. Yes. So we covered deviation by less than 60 degrees, and after that there are some cases where there is no TIR. Did we cover that? Okay, settle down fast. The blocking you did? Can say. Okay. So there are cases, case of 30, 90, 60 degree, no TIR. Right? If the ray is inputted on a 30, 90, 60 degree prism from these two sides, is the diagram visible at the back? Let me know. Can you read what is written? 60. If the ray is incident, what is it incident? If the ray is incident from this side, what is the angle of incidence here? What should be angle of incidence there? 0. Not here, here. 30 degrees. I'm impressed. आदित्य राइट? ठीक है और क्या है? जल्दी से बोल। सही बोला है। कैसे सही है बता? कैसे सही है? ये 90 है, ये 60 होगा, ये 30 होगा, ये 30। तो अब क्या होना चाहिए यहाँ पे? टीआईआर होगा कि रिफ्रैक्शन होगा? टीआईआर होगा, यही उम्मीद की तुम। क्या है ये? मटेरियल ग्लास है। ग्लास का क्रिटिकल एंगल क्या होता है? What is critical angle of glass? 42 degrees. And the angle of incidence is 30. So this is not a case for TIR. क्या होगा? Refraction. So refraction मतलब it will go to the next medium and it will go away from the normal. It will go away from the normal. Okay. So it will be greater than 30. So in this case, no TIR. Okay. Refraction will take place. So this is the exception. If the ray was inputted from here, we saw that it is deviated by less than 60 degree. Okay, but if it is inputted from either this space or this space, so it makes a case of no TIR. There is one more case for no TIR when the ray is inputted from incident from this direction on the hypotenuse. So look for the second case. So there are two cases for no TIR. One is incident on face AB, the other one is incident on face AC, which is hypotenuse. Again, the incident ray is along the normal. So where it will go, it will proceed forward. So what is the angle of incidence here? What is the angle of incidence here? So this must be 90. So this is 60. Again, this is 30. Right? So this is also refraction. So no DIR is also. Okay, this is no DIR here. Okay, again refraction is taking place. But there is an exception on this space. If the ray is incident, okay, within this region, you draw a perpendicular from this, from point P. If the ray is incident within this, then it will suffer DIR. Okay, so what's the exception here? These two cases, when the ray is incident from face AB and AC, there is no TIR till it is incident within this region. From vertex B, if a perpendicular is drawn on hypotenuse, and if the ray is incident within this, then there will be a TIR. Okay, so let's draw. I will not draw a different diagram. I'll draw here itself. Or should I draw a different diagram? Can you stretch that board? So stretch that so that I can see the board. Keep here. Mouse is right here. पूरा कर. Oh, wait. Wait. Let me draw a different diagram. So I'm drawing a diagram for exception. Now when the ray is inputted here, normal. This is 90, this is 60. Right? So this becomes 30 now. So what is the angle of incidence here? This is 60. Okay, so this is greater than critical angle. So now it will suffer TIR. At this point, there should be TIR. Now this is 60. Therefore, this is 30. And this is 90. Therefore, this must be 60. This will be 30. So again, there will be refraction. Okay, so this point is refraction. Right? Okay, so is it understood? So there may be a question. Using 30, 90, 60 degree prism, draw the ray diagram for cases where no TIR is possible and when TIR is possible. So there are 4 cases with 30, 90, 60. What are the 4 cases? Deviation less than 60 degree, 2 cases without TIR, and 1 case with TIR. 4 cases of it. Is it understood by everybody? 4 cases were just look at the diagram and see the difference. We have this case in others. All these 4 diagrams in others also. Duty volume it is there, not in others. Okay, so any queries here? Is this diagram understood by everyone? You can just see the navigation and draw the angles for yourself. Right? So very easy. This is 90, this is 60, 30, 60, and likewise. Just follow through. Pure geometrical construction. This is exceptional. So with this, we have completed this chapter. What was it? Refraction of light on right plane surface. This chapter is completed. You have any queries you can ask, or else we'll go for very good. So in Selena, there are some consequences of refraction we can discuss. This is what is observed in daily life. These are daily life experiences based on total internal reflection. So we can discuss this. Okay, can I discuss? Let's discuss some consequences. Their experiences from daily life. So first consequence is the phenomena of mirage. So have you heard of mirage? Have you heard of mirage, oasis? So this takes place due to total internal reflection. So what is oasis? A feeling that there is a water body in a desert. But actually when you reach there, it is not. Okay. So what happens is, we'll actually understand it with the help of red eye. So let us say there is this is a desert. Okay. Somebody is walking here. Some observer is here. Let us say some camel. Okay. Somebody is sitting here. And he sees some tree. Okay. Far away there is a tree. And he sees the image of the tree here. Now the image, when the tree image is possible, when there is a water body, right? So actually what happens, this is sand, right? Hot sand. So the air in contact with hot sand will be hot, right? So hot air. So the air which is in contact with hot sand will be hot. So it will have less density. So it will be optically rarer. This is optically rarer. The air in contact with the sand. And the air which is above, that will be optically denser. Correct? So let us say, so there are two types of air. The optically rarer air and optically denser. So now, at a certain position of this, right? So the light coming from here will be reflected to the observer. Okay, at certain position. And then its reflection will be being here. Okay, at a certain angle, the light will be totally internally reflected because this is denser to rarer, right? So this situation is forming at this distance. The moment he comes close, the TIR condition is violated. Okay, so critical angle is forming here only at this position. So as it comes close, then there is no reflection. Is that clear? This is what is mirage or oasis. Is it understood? It's only the same medium, but due to hot and cool, this is cool air. Cool, dense air. So this satisfied the conditions for total internal reflection. The light rays traveling from denser to rarer medium, and somewhere the TIR takes place. So this is the point where TIR is taking place. Okay, so this is mirage formation. What is the second case? An empty test tube placed in water in a beaker with mouth outside the water surface shines like a mirror when seen at certain angles. So these are the cases given in Selena. I don't know if it is given in Brothers. So what is the second case? Very flexible and agile. Take some practice. Okay. Okay, so what is it? So that's why it's a caution of the don't take chances with me, especially you guys. Okay, so if a test tube is put inside, what is this test tube? Empty. So you have air here. This is water. Right? Now, if somebody is seeing inside the test tube, okay? So now the ray is traveling from rarer to denser. So at a certain orientation of the test tube, total internal reflection will take place, and therefore this acts as mirror. Okay? So the test tube will appear like a mirror, so you will see yourself inside the test tube. So basically, at certain orientation of the test tube, TIR will take place. Okay? At a certain angle. Now, these are things that you can observe at home. Right? Create conditions where the light rays traveling from rarer to denser. And at a certain angle, then the test tube, otherwise, when you take the test tube out, then you see that it's better off. But when the TIR condition is small, when the TIR condition is very low, how do you miss it? Go sign and come back. So only at a certain angle you will see that the test tube is acting like a mirror. But when you take it out of water, it's active. Okay? So pure TIR conditions forming there. Third, a crack in a glass vessel often shines like a mirror. Have you observed it? Any glass is cracked. So at the place where it is cracked, you can very easily see that it shines like a mirror. Have you seen that? The crack shines. So there are a couple of things you can do. You can go home, break the glass of a window, wall, or उसमें crack आ गया and the glass is still in place. I'm talking about crack, not two parts. Okay, so you can see it somewhere. I don't know where. Just see images on Google. Okay. So I don't know if you're getting what I'm trying to say. Whenever a cracked glass is still joined together, so in the crack, the air seeps in. Okay, what has happened in the crack? In the crack, the glass seems joined, but in the crack, the air seeps in. Now there are two mediums created. And then when you see at a certain angle, the crack, only the cross-section part of it appears like silver shine, like a mirror, because it is now reflecting everything back. That's how you can very easily see the crack. Okay, is that clear? So this is the third one. Fourth, a piece of diamond sparkles when viewed from certain directions. Now diamond. So what was this? Crack mirror. Crack glass. Here's the item. Crack in a glass. Here's like okay. Okay, fourth. What is fourth? A piece of diamond sparkles. Sparkling of diamond. So sparkling of diamond. So the impression that diamond is glittering. Is diamond a luminous object? Is it producing its own light? No. So what might be happening? Somehow when the light enters inside diamond, right? So there is a technique of polishing and cutting the diamond surface in such a way that the light which is incident, when it hits the diamond surface, it suffers total internal reflection, as many as possible. So the light entered once just reflects and then it glitters or sparkles. So that gives you sensation of glittering of diamond. Okay, so that is happening because of TIR. Now where is TIR? Once the light is entered inside diamond, now diamond is a denser medium. When the light is trying to come out of diamond, outside is air, and then the TIR is happening. Okay, that's how they sparkle. So all these cases are consequences of TIR. So that was sparkling of diamond. Then fifth is optical fiber. Is it correct? So are you familiar with optical fiber? Everybody using optical fiber these days for internet connection. So everybody has internet Wi-Fi, right? So that Wi-Fi that comes to your house, the carrier, that carrier is made up of optical fiber. So it has very large bandwidth, and all the signal or data that comes to your house is an optical signal. Okay. So basically, what happens? But we deal with computers. So what is the signal here? It is electrical. So there is an opto-electrical converter in the modem, which converts the electrical signal into optical signal, and then it is carried over the fiber optic, and at the other end the reverse conversion takes place. There is another optoelectrical converter at the other end, which converts it back into electrical thing. Only the carrier part, when the data is being carried, it is carried in the form of optical signals. Okay. So optical fiber क्या होता है देखो. Have you seen optical fiber? The strand of optical fiber. So there are people who sell decorative lamps. Okay, you must have seen the decorative lamp. There are so many strands coming out, and at the end of the tip of the strand, you will see different colored lights. Have you seen that? Huh? एक मिनट इसको एक जरा सर्च कर. Open browser. Okay. Optical fiber decorative lamp. L small care. ठीक है. Small L. Optical fiber decorative lamp. हाँ आगे. हाँ, have you seen this? Can you see the tape? So this is like a light carrier. Okay. I'm sure everybody must have seen. Now, सबको समझ आ गया? Okay. So what is the purpose of optical carrier? Okay, Bankar. What is the purpose of optical fiber? It is a light carrier. Like if you have a water pipe, it carries water, right? So as the pipe is turning, water turns along with it. Just like that, in optical fiber, the light will travel as per the dimension of optic fiber. So can you imagine light bending? It cannot, right? Light travels in straight line path. But inside the optical fiber, it is a light pipe. Okay, so light travels as per the orientation or as per the geometry of fiber optic. It's a conduit which carries light, just like water flows through a pipe, and it turns as the pipe is bending. So what happens is, so if there is a light source, generally light will travel in a straight line, right? But imagine there is a fiber of optical fiber which is shaped like this. So this optical fiber has a glass fiber. It is a glass fiber, transparent. And there is an outside coating. Okay. So if you see the cross section, it is like this. Now, the inside material has a lower refractive index. Okay. Sorry, high refractive index inside. This is 1. And the outside coating has lower refractive index. Right? This is how the optical fiber is designed. So these are basically combination of two materials. The fiber strand is inside and then the coating. So coating has less refractive index. So this is how it is. Now when the light is, let us say the light signal is made to enter in the fiber optic. Okay. So here it hits the boundary and then gets internally reflected. This is how it goes. You understand? So now you can guide or navigate light direction as you wish. So where is it used? Now this optical fiber strand is very thin. So where is it used? It is used in surgeries these days. So now instead of making a big surgical cut, 3 holes are drilled. So you must have heard about what is it called? हाँ? नहीं उसका कुछ अजीब सा नाम है वो गॉल स्टोन के लिए सर्जरी करता है उसको क्या बोलते हैं लेप्रोस्कोपिक सर्जरी so in laparoscopic surgery only 3 tiny holes are drilled so 3 fibers are used 2 fibers are used or only 1 fiber as a light source the other hole is used for putting in the camera and everything the internal thing of the body is visible on monitor. So you can't enter a torch and then a camera, right? I mean, so fiber, so this is flexible, right? Very thin. So the light source is entered inside. Then you have the surgical instrument, okay? That is in the second hole. So you have instrument, you have camera, and you have light source. That's it. And with the help of monitor, the surgery is completed. With this, the healing time, which used to take months earlier, now within 2 days the patient can be discharged. All stone it has become a child's play now because of this. So this is because you can carry light the way you want and in odd locations. So these things have become possible. Now this is one thing, and otherwise it carries signal, which is noise free. It is not an electrical signal. What is it? It is light signal. Okay, so it is noise free. So we have undersea carriers which are made up of fiber optic, and now distortion free communication is cross continental distortion free communication is possible because of this. Okay, so that's what we are going to have. So doctors are going to do surgery remotely now with the help of AI, etc. वो सब सुन रहे हो ना? It has become possible because of this. All right. TIR. What's the point? TIR. Where is TIR taking place? Here. Everywhere where the critical angle is, angle of incidence is more than critical angle, this is happening. Is that clear? Okay. So with this, we have completed your chapter number 4. Right. So how is the situation on homework? Everybody doing it? वो inclined plane का देखा मैंने. It has a different mechanical advantage. Right? So load is given in the question. Right? So effort निकालना है ना. So MA of inclined plane is equal to load upon effort. So inclined plane के लिए जो MA होता है, it's like this. The length of the inclined plane over height. So L by H होता है, L by H. So what is E therefore? तुम्हें E निकालना है क्या निकालना है? H निकालना है ना? So you can find H there. ठीक है ये बट वो है नहीं सिलेबस में है नहीं है वो ऐसे निकाल सकते हो ठीक है और किसी का कोई क्वेश्चन रहेगा था क्या लास्ट दैट वाज ओनली वन ओके लेट अस डू क्वेश्चन फ्रॉम दिस चैप्टर okay then everybody open page number 70 page number 70 of your volume page number 70 there is a difference between total internal reflection and reflection from a plane mirror. Just read through the differences. See if you require any explanation. मेरा बॉटल गिरा दिया मेरा सर है इधर नहीं तो इधर इधर सर वो कोने में नहीं नहीं ये देखा नहीं रहा ठीक है इधर बैठ Do you need explanation in these 3 points? What is the difference between TIR and reflection by mirror? Read all the 3 points. Right. First one. What is the first one? Any medium. पानी के अंदर भी शीशे में देखेगा तो खुद को देख पाएगा वैसे तो हवा में देख रहा है ना Right now we are in air. We can see ourselves in the mirror, but through water also you'll be able to see yourself. Right. The last point is important. The last point. Why should we consider TIR for image formation? It is because of the last point. The image will be much brighter in case of total internal reflection because there is no energy loss. In reflection by mirror, some of the energy is absorbed by the mirror. So the image quality created by TIR will be much better. Okay. All right. Now come to okay, let's do numericals first, then we'll go to the review questions. Come to numericals, page 76. So this chapter has very few numericals, right? But lot of ray diagrams. Let's do numericals first. So how do I, there are only 6 numericals in the class work. What is the first one? Speed of light in air is given. Let me calculate the speed of light in glass. Then refractive index of glass is given. So how will you do it? Yes. Distance upon time, है ना? Calculate the speed of light in glass. So first write down the given data. Also write down what you are supposed to find. And see which formula is applicable. Which formula will be applicable here? Yes. So it is the absolute refractive index of glass, right? Since absolute refractive index of glass is given as this is by definition of absolute refractive index. So what is VG? So very straightforward. So this will be 30 by 15. That is 2 into 10 raised to 8 meter per second. Okay, so you have to remember the 4 or 5 formulas related to refractive index. So relative refractive index and absolute refractive index. These are the only 2 categories of formula. Next question. What is this? The angle of refraction is less, but the second medium is denser, right? This is the formula, right? So angle of refraction is in the second medium. This is sine 60 divided by sine 45. What is sine 60? Root 3 by 2. And what is sine 45? 1 by root 2. So this will be root 3 by 2. Now the values are given. So you can directly write the values here. 60 is it's 0.866. Should be 0.866. Right? Let me confirm the value. And this should be 0.707. Right? So when you solve it, you will get 1.22. Do the correction. I think there is a typographical error. What is given is sine 60. Yes, sin 60 is 0.866. So it is 0 point. Just write in your volume. It's not 0.86, it's 0 point. हाँ. और हाँ, this is actually easier thing, है ना? वो जल्दी easy आ जाएगा. What is, you know what? This is एक ही बात है यार. वो root 3/2 भी करोगे ना, तो 0.866 आएगा. ठीक है? तो अगर तुमने इसको ऐसे किया root 3/2 into 1/√2 मतलब ये √2 आ जाएगा. कैसे? ठीक है? हाँ, तो ये तुम ऐसे भी कर सकते हो. 1/2 0.5 into 1.71, right? Into 1.41. 1.7 या 73 होता है. तो ऐसे भी कर सकते हो. So multiplication is always easier than division. तो वैसे कर सकते हो. Either ways you can do it, okay? Just find what suits you. Both way you'll get the answer. So two ways to calculate transfer is given to you. One is by using the more values of sin 60 and sin 45. Another is this 0.707, it is 1/√2. Okay, 1/√2 is 0.707. 3/2 is 0.866. That is given in the textbook. Okay, shall we go to the next question? So the next question is, question 3. So what is this situation? You have a beaker in which a coin is placed. Four by three. This is 4/3. Then what is given? What is given? The total depth 12 centimeters. They have to actually find shift. In this case, you have to find the height by which the coin is placed. You have to actually calculate. Everybody understood the question? क्या करना है यहाँ पे? क्या निकालना है? By what height the coin is raised? तो क्या निकालना है? Shift निकालना है. Okay? So What is the formula for shift? X is equal to, this is the formula, right? The formula for shift is X is equal to period F plus minus 1 by refractive index of the medium. So basically, this whole thing is T. This is X. And this thing is called D. Right? What is this? So it should be 3 centimeter. Four. What is question 4? फॉर्मूला समरी दिया था ना मैंने रिफ्रैक्टिव इंडेक्स का. Not formula summary. I think I have given you formula summary for refractive index. ठीक है, उसके बाद एक ही तो फॉर्मूला है. देखना ठीक है, चलो ये फॉर्मूला लिखो. दिया है ना? हाँ ये दिया है. इसके अलावा 2 ही तो फॉर्मूले हैं. कौन सा फॉर्मूला है? इसके अलावा जो फॉर्मूले हैं ये वाले I प्लस एक ये और क्या है? एक ये बस. और क्रिटिकल एंगल का फॉर्मूला है. क्या है क्रिटिकल एंगल? ये हो गया. और इसके बाद ये था रियल डेप्थ. हाँ ये शिफ्ट है. ये शिफ्ट है. ये एपरेंट डेप्थ, क्रिटिकल एंगल or a relation between all the angles of the prism. This is it. This is apart from the formulas for refractive index. These are the only other formulas. यहाँ पे देखो refractive index लिखा है, वहीं पे लिखो इसको. क्यों क्या हुआ तेरे को? चुपचाप बैठेगा? ठीक है, अकेले बैठ उसके पार्क के पीछे. लेकिन मैडम ने क्या बोला? मीना मैडम ये तो लेकिन शुरू से बोला गया ना आगे बैठना है, तो पीछे कुछ हो जाता है तेरे को. ठीक है, चुपचाप बैठो. लेट मी सी. वो भी बैठेगा चुपचाप? हाँ ठीक है. ठीक है, तो मेरी वाली वॉल्यूम यूज करें. 2 वॉल्यूम है क्या? मेरी वॉल्यूम किधर है? क्यों नहीं लाया? तो यार सभी के बच्चे हो कि पहली दूसरे के समझ में नहीं पाते. Okay, so we did question 3. Let's do question 4. Is everybody okay till here? और कभी तेरा नंबर आगे बैठ गया. I don't know any of that. Also the questions. So you don't need a diagram for this. Pratyush, you don't need a diagram for this. What is given? Angle of incidence is given. It is this diagram, no? This is a I1, I2. ये तो है, उसमें डायग्राम क्या बना है? तो ये नहीं आता तुमको बनाना. प्रिज्म का जो डायग्राम है इक्विलेटरल, उसका एक ही डायग्राम है. बेस से ऊपर जाएगा, मिड पॉइंट पे हिट करेगा, then it will become parallel to the base, and while coming out again it will bend towards base. यही लॉजिक है उसका. And this will vary. This is angle of incidence. This is angle of deviation. This is angle of emergence. This is angle of prism, and it's given. And you know the relation. What is the relation? This is the relation. You have to just use this, nothing else. Okay? So therefore, what is the solution here? Since I1 plus I2 is equal to delta plus A, what is I2? Minus I1. Okay, what is deviation? 45. Now it is given that it is equilateral prism, so all angle will be 60 degrees. A60 is equilateral. This is given. So you have to infer that. Okay. So 45 plus 60 minus 72. How much is this? Minus 12. So 23. 33. Okay, so the numericals are simple. So we remember the formula and the contents. Question 5. Yes, because this is for minimum deviation. So minimum deviation is a special condition. Often from the same form. Now question 5. What should be the angle of incidence? Angle of minimum deviation is now given. How much is this? 36. through equilateral prism. So equilateral में फिर से ये you have to take 60. Solution में sense. What is it? 36. No, 96. 48. Okay, so this is the answer. Next. Question 6. The refractive index of water with respect to air is 4/3. What is the refractive index of air with respect to water? I want you to answer this. उल्टा हो जाएगा, reciprocal, है ना? Very good. So what is it? Given refractive index of water with respect to air is equal to 4/3. Therefore, what is equal to 1/AW. For new AW is equal to 1/AS. देखिए क्या हो जाएगा 1/4/3, that is 3/4, which will be 0.75. So purely we have seen that all of them are formula based. Okay, so numerical in this chapter are very easy. What will be difficult is completion of ray diagram if you don't get the context. Okay, वहाँ पे critical angle and where TIR will take place, where refraction will take place. So we'll now do some questions of application type. So there are about how many? So many, 18 questions. So let's do this. Application type questions on page number 77. So anybody has any doubt in these numericals? The 6 numericals that we discussed. Everybody comfortable? If you remember the formulas, then just so now we'll take turn in solving application type. Some of you may have to come on board to read questions carefully. Application type question. This is on page, same page, page 77. So everybody draw this diagram. I'll come and check. Draw the diagrams to show the refraction of light from air to glass, then glass to air, In each diagram, label the incident ray, refracted ray, the angle of incidence, and the angle of refraction. Back is ऊपर ऊपर रख दे इधर. Could you draw your diagram without bothering others? Anyone who needs help, call me. Don't talk to your friends. I'll let you in this. By the way, did you write the exam last Sunday? How did the exam go? That is the type of question expected in board. Application type. हाँ? हाँ? इसको नहीं कन्वर्ट किया? हाँ, तो इसके लिए तो ठीक है ना, मतलब see, you will make mistakes and learn. So don't be too shocked if the results are not favorable. Take it as a learning and be careful where are you making mistakes and then don't repeat it. ठीक है? अभी जो टेस्ट के मार्क्स है उससे बहुत ज्यादा दुखी होने की जरूरत नहीं है. Figure out what are your weak areas. Okay? Do the analysis where you need more help or more effort. Yes, don't be too dejected by the result. But identify what are the weak areas where you need to work on. Your questions are going to be like that only. All right. So, who has completed the ray diagram? Raise your hands. Okay. Okay, everybody pay attention here. So far, we have learned that this is read as refractive index of second medium with respect to first medium. There is one more way to write this. It is written sometimes like 1 mu 2. Okay. It is still read as this only, refractive index of the second medium with respect to first medium. This makes it clear that the incident medium is 1. You get it? So now that's a typographical error. So what is it? What should have been written there is this. So what does it mean? It means so this is what is written there. So in your numerical, somewhere in the homework numerical, which question is that? Third question. So you see, everybody see homework numerical question number 3. This is just another style of writing refractive index. There is no difference between these two. There is no difference between these two. Just the incident medium is written first. But how do you read it? You still read it like this, refractive index of the second medium, the refracting medium, with respect to first medium. Okay? So while if there is a question and the refractive index is mentioned like this, it means this only. Okay? These are interchangeable. Just the way of expressing. Clear? Solution for this some model answer is there. So उसका expression Okay. So have you completed the diagram? Completed? Also, so everybody understood the question. Did I tell you you're not going to discuss among yourself? Anybody who is down supposed to call me and discuss with me. अभी वोट नहीं करूंगा. I'm just checking how you guys are. So far, not satisfied. Many of you have not understood the question only what is asked. This is supposed to be the simplest question. What is asked is this. Okay. This is what is asked. So I told you this is air. This is glass. A lot of you have drawn rectangular glass slab and then taking it out from the glass slab itself. It's not that question. Just two mediums, air and glass. Then you have to label. So PQ, R, AB. That's it. So what is the incident ray? Either you write incident ray here. This is incident ray. So PQ is incident ray. UR is refracted ray. Right? Normal. The whole chapter is this. So this is the first part. You have to label the incident ray. So either you write incident ray here, okay, right here, or you can show it like this also. Okay? An angle of incidence. You've labeled it. That was air to glass. Second, glass to air. How will you do glass to air? Let's say this is glass. This is air. What should happen when it goes from glass to air? Away. Okay, same thing. So this question, the examiner wants to check angle of deviation, whether it is going towards normal or away from normal. You have to specify the medium temperature, glass and air. So draw this. Everyone understood now what was expected? But to only show the mediums clearly, well labeled diagram. Now PQ, QR, both cases are incident ray and reflected ray respectively. R is angle of incident. Yes. The base. Okay. Now, what's the creating? Last to that, last week. It's okay, it's okay. What's the logical question? The first is will speed up, so speed increases, right? Yeah. Second question is a logical question. Question 2. So light ray travels from water to light ray. Water to air. Will speed up. Water to glass. Okay, will speed up, and what you can write down? And bend away from normal. From normal. Is the diagram asked in the second question? Only asked about how the speed will change. That's it. Not required. Okay? So speed will, or you can water to air speed will increase or speed up, whatever. Speed will increase. Okay? Conveys the message. Next. Now question 3. Got it? Everybody, let's discuss question 3. So who would like to answer? Raise your hand. Name the ray which represents the correct path of light while passing through the glass block. 2 hands. B is the correct? There is a close contest between A and B. नहीं हो रहा है? Why A is not correct? Normal की दूसरी तरफ है. Okay. So it is only B, right? Only B is correct. Because C is the original path. What is C? C is the. Is everyone with me? So what is C? C is the original path, and B is the deviated parallel ray. Parallel ray. Okay, this is laterally displaced. B क्या है? Lateral displaced. ठीक है. So B is correct. Let's discuss question number. So question 3. Where B is correct. So let us complete question 4. Has anyone completed question 4? What is this angle? 45 degree. And this one is 30 degree. This is liquid. This is air. Question 4 completed. What is given in the question? Angle 1 is 45. Angle of incidence in air and angle of refraction in liquid is 30. What is this? This is a mirror. So it will reflect. What should be angle of reflection? What is this angle? Alternate angle. This normal of the mirror must be parallel to normal of the water surface. So this is 30. This also should be 30. So this is 30. So now what happens here? Again, this is 30. Since this is a reflected angle, it must be 30. Again, normal. So this is also 30. Correct? So this must be 45 then. This must be 45. So it is symmetric. What is happening at the base is reflection. ठीक है ना? So law of reflection should be applied at the bottom. Law of refraction. Yes. Depends. At minimum deviations. Yes. Okay, everybody done with question 4? Proceed to 5. Question 5. Everyone, draw the diagram. So what happens to the incident ray at minimum deviation? Parallel होता है, refracted ray is parallel to the base. वही diagram. What is the incident ray? Incident monochromatic ray. You have to write it. Incident monochromatic. This is not white light. Okay. Angle of incidence. This becomes angle of emergence. I1 is angle of incidence. I2 is angle of emergence. QR is refracted ray. Do you have to show angle of deviation? So the first part is at minimum deviation. Angle of incidence is equal to angle of emergence. The deviation you have to show as delta M. What do you have to show? Delta M, because this is the case for minimum deviation. Illustrate your answer with the help of label diagram using an equilateral prism. Okay.